As promised, I have Jessica next to me. Hi, Jessica.
Hello.
Come a little closer. Don't be afraid. So I was one of the people listening to your speech. Everyone was so concentrated. It was silence here by the screen. So I think it was really interesting. How do you feel about your presentation?
Yeah, I'm glad if people learn something, and yeah, then that would be great.
We can talk about quantum computers just a little bit more in a moment. I just want to present more information about you because you do so many things, and I'm not sure if you mentioned that in the beginning. You are engaged in quantum computing research at Stanford University, Harvard University, and Massachusetts Institute of Technology. You're a PhD student. You've been an intern at Google, management consultant at McKinsey, investment banker at Goldman Sachs, and strategist at Morgan Stanley. You're also one of the top 5% of the class at Harvard. You're super talented. Wow, that's amazing.
Thank you.
It's really cool. So how do you put so many talents under one roof?
I mean, I did all of these at different times. Yeah.
Still, that's a lot.
Yeah.
Yeah. So you're very kind and don't like to brag about what you do, right?
Yeah, I should know. I did internships at these companies, so I'm doing my PhD now, and did those internships in the summers in my undergraduate career. Yeah.
How did you become interested in quantum computing? What were the first steps?
Yeah, I think I mentioned in my talk. The spark started 10 years ago when I was a young girl in middle school or primary school, and I went to this technology camp, and they showed us this really cool experiment with the superconductors, and they told us about quantum physics, and I was like, I never learned this stuff in school. You know, this is really fascinating, and sort of that made the spark. And then it was actually until college when I actually took a class in quantum computing and then started doing research with a professor there. And I was like, oh, this is really cool, and I'd like to be involved.
So you're the first person I'm talking with who has some real life experience with quantum computers, because all we know is from articles, and not so many people have a chance to work with that with these. So what do you do exactly? You program. What do you do?
Yeah. So I'm more on the programming side. So I mentioned in quantum computing, there's two main sides: the hardware, so trying to physically build the quantum computer, and then like the program, right, trying to program it. And I do more the latter one. So basically trying to design new quantum algorithms, so new instructions for the quantum computer to solve a particular problem. I've done some projects in machine learning and in like chemistry and physics simulations. So working on a bunch of cool projects.
If someone saw a picture of quantum computer, it really looks like something from a computer game. You know, it's like unreal, like a huge lamp. I don't know. I wanted to ask, because some people doubt that. Is it right to call quantum computers computers? Isn't that essentially something new, and we should maybe think of a new word for that? What do you think?
I think the definition of computers, from my understanding, is you process and you store information. So I think in that term, a quantum computer is a computer, but funnily enough, it's more for the processing side rather than memory, because as I mentioned, these quantum states are very fragile, so it's hard to do memory with it, but you do processing. So I think it is a computer in that it does process information, and we can solve types of problems. But you bring a good point in that it works completely differently. It's not, just a faster computer. It's actually completely fundamentally different. So we do have to rethink the way we sort of, compare it to normal computers and how we think about programming them.
Because I think there are still a lot of people who think, oh, quantum computers, I guess they'll make my computer load the stuff faster. Like, that's what happens.
Yeah, so that's not true. Is that, because it's completely different. It's not just faster in anything. You have to be specific in what you're finding.
So since there is so much hype about quantum computing, could you mention a few things that quantum computer won't be able to do?
Yeah. So, it's always hard to prove what something can't do. So I don't know if I can prove that a quantum computer cannot do something. But I like to think that a quantum computer is sort of, it's working alongside a normal computer. So, for example, you could do arithmetic on a quantum computer, but actually it's way more efficient to do that on the classic or on a normal computer because it works completely differently. So there are some things you don't want to do on a quantum computer because it's going to not be as efficient. Yeah.
Okay.
Yeah.
So, and the research that you're doing at the moment, I was wondering, are you doing just some fundamental researches, or are there any companies that are looking behind your back and like waiting for you to finish so they can implement that? Is that happening in the quantum field?
Yeah, so I'm doing research and actually I collaborate with some companies in the research. So I've been collaborating with Google on a project, for example, and as I mentioned, I'm currently doing an internship at NASA. So actually, the quantum computing field, I would say there's a good academia and universities are working nicely with industry, and it's really a team effort between both of them.
Yeah, but does the industry knows what they are going to do with that? Do they have their ideas, or they're just like so interested in that it's so new they want to put their hands on? But do they really know what they're going to do with that?
No one really knows. I mean, as I mentioned, there are some applications that we think a quantum computer will be good at, like chemistry and physics simulations, maybe machine learning. But we haven't actually demonstrated like a useful problem to be run on a quantum computer. So that's why it's really exciting, because this is the next step. Yeah, so hopefully we do that.
That's kind of crazy. Like, you have this kind of new thing, quantum computing. It's super new, super expensive to do. Nobody knows how it works. Nobody knows what is it going to do. And everyone is super hyped. So that's kind of a strange thing to do.
Yeah, I guess. I mean, I guess there has been a lot of theory around quantum computing, so that's why we do know it could solve some problems faster. As I mentioned with the encryption, we know theoretically it could break encryption. But the big thing now is, like, can we actually run that on a real quantum computer and actually, do that for a big problem? So.
I know in Lithuania we have some quantum chemistry professors who are working on that. So they mentioned they mentioned me that they can explain why tomato is red by using quantum chemistry, and just like explode in my head. I'm not going to go to the details.
Okay.
So, and how do you enjoy the conference? How do you like it so far? It's your first day here, or have you came before?
Yeah, so it's my first time here at this conference, and I think it's great. It looks very interactive, and I saw this basketball thing. I've never seen that at a conference before.
Lithuania is famous for the basketball, so it's always someone is playing that.
Okay, yeah, I think that's really cool, and it seems like it's really fun. You can just go do different things, and I'm really glad to speak on quantum computing and sort of get people thinking about the future, what's the future of computing. So.
Have you met any other developers who are into quantum? Have you received a lot of questions after the talk?
Oh yeah, I did. Yeah, lots of people actually asked how they can get involved in it, which I'm really happy about. So I think maybe next time I give a presentation, I'll give a list of resources, because a lot of people ask about books or courses or ways that you can actually start programming on a quantum computer. And I mentioned some of these resources in the presentation, but so yeah, I'm glad that they. Yeah.
So thank you, Jessica. It was really a pleasure having you here and having to know quantum computers a little bit. Just before we move back to Agne, if not quantum computing, what else do you do? You have so much in your head, so many universities you attended, so many internships. I just want to ask you, how do you plan your time? Is it very strict? How do you manage that all? I started from that. I want to get back to that. How do you manage that all? So teach us a little bit.
Yeah, I mean, I don't know. I guess I plan my time and I guess prioritize what matters to me. So I do a bunch of other things. I started a quantum computing club at Stanford, so we actually do some sort of we do events and stuff like that. I'm involved in a Bible study group, so I do those sort of things. I like to go running. So I don't know, just planning and prioritizing what matters. Okay. Yeah.
That sounds very easy. It's not.
Okay. But yeah.
Okay, so thank you, Jessica.